In the right side short-axis view of the aorta, the pulmonary valve is to the right side of the aorta on the ultrasound screen. The right ventricle is above the aorta and the pulmonary valve, and the main pulmonary artery is below the pulmonary valve. During right ventricular systole, blood flows from the right ventricle through the pulmonary valve and into the pulmonary artery. Ideally, you position the pulmonary valve directly in the center of the ultrasound screen so that a spectral Doppler cursor can be placed through the valve for a flow velocity measurement. In most cases, if you angle the transducer toward the patient's head, the cardiac image on the ultrasound screen moves to the left side of the screen and the pulmonary valve can be centered. We can use color flow to help evaluate all valvular blood flows. When activated, Color Flow Doppler assigns colors to blood flow moving towards or away from the transducer. The transducer is located at the top of the ultrasound screen. The standard color flow map uses the BART system, where movement away from the transducer or down is shown as blue, and movement towards the transducer or up is shown as red. BART, blue away, red towards. It is possible to reverse these colors, but we do not want to do that. The best color flow or spectral Doppler measurements require low-frequency transducers. Most ultrasound machines automatically default to the lowest available transducer frequency when Color Flow Doppler is activated. The two-dimensional cardiac image degrades, and a color flow box appears on the ultrasound screen. Use your trackball or touchpad to move the color flow box around the screen and place it over an area of interest, in this case, the pulmonary valve. A color flow indicator appears on the upper left or right side of your ultrasound screen. The indicator, or icon, shows that upward movement is red and downward movement is blue. The indicator also shows the current Nyquist limits as a number in centimeters per second at the top of the red bar and the bottom of the blue bar. Color Flow Doppler requires a tremendous amount of computer capacity. Maintaining a two-dimensional cardiac image also requires a tremendous amount of computer capacity. The area of color flow interest should be centered on the ultrasound screen. Therefore, we really do not need to look at the entire two-dimensional image. Most ultrasound machines allow you to reduce the ultrasound beam or sector width. By doing this, you reduce the amount of computer capacity needed to generate a two-dimensional image of areas that you are not currently interested in. This makes more computer capacity available for generating the color flow image. You must be familiar with the functions, capabilities, and operations offered by your ultrasound machine. With most ultrasound machines, the trackball or touchpad is used to move the color flow box to the point of interest. Most ultrasound machines allow you to change the size and shape of the color flow box to suit your needs. In many machines, when color flow is activated, pressing the Set or Select button allows the trackball or touchpad to increase or decrease the size and shape of the color flow box. Side-to-side movements of the trackball or touchpad increase or decrease width of the color flow box. Up or down movements of the trackball or touchpad increase or decrease height of the color flow box. The color flow box should be large enough to show both sides of the valve studied and any flow disturbance in either direction. When you're satisfied with the size and shape of the color flow box, press the Set or Select button again to maintain the adjusted color flow box size. Most ultrasound machines have a knob or toggle to allow you to increase or decrease Doppler gain. When gain is too high, color speckling occurs in both fluid areas and tissue areas. If speckling is present, decrease Doppler gain until speckling of tissue areas disappears. Normal blood flow velocity through each cardiac valve is at or near 1 meter per second or 100 centimeters per second. Ideally, we would like our color flow Doppler to show pure blue for flow away from the transducer and pure red for flow toward the transducer. The Nyquist limit is the velocity at which aliasing or wraparound occurs. In color flow Doppler, aliasing is a change of colors indicating flow exceeding the Nyquist limit. Blood moving through the pulmonary valve should be blue because it is moving away from the transducer. When the Nyquist limit is exceeded, the color changes or wraps around from blue back to red, even though blood flow is still moving away from the transducer. The color flow icon or indicator shows the Nyquist limit both away from and towards the transducer, with a baseline of 0 flow in the center. Red and the positive Nyquist limit indicates flow toward the transducer. Blue and a negative Nyquist limit indicates flow away from the transducer. Ideally, we do not want to see aliasing unless the blood flow velocity is abnormal, that is, greater than 1 meter per second. Doppler limitations are a function of transducer frequency, depth, and computer capacity. The higher the transducer frequency, the more limited the Doppler capability. As you increase depth, Doppler capability decreases. For example, this phased array cardiac transducer has a variable frequency of 5 to 8 megahertz. The Nyquist limit of the color flow Doppler begins at 44 centimeters per second on a high blood flow setting. This Nyquist limit is set for the maximum depth of the transducer. I can raise the Nyquist limit by increasing the pulse repetition frequency, or scale, to 78 centimeters per second. If I move the color flow box to maximum depth, the Nyquist limit automatically reduces again to 44 centimeters per second. If I move the color flow box back to the top of the screen, I can increase the PRF, or scale, to raise the Nyquist limit back to 78 centimeters per second. Now, if I decrease the depth to 11 centimeters, I can increase the PRF, or scale, and raise the Nyquist limit to 93 centimeters per second. To get better color flow Doppler, I need to change to a lower frequency transducer. So, in using color flow Doppler in cardiac settings, you should increase the PRF, or scale, to raise the Nyquist limit to match flow velocity through the valve. For the arterial valves, the Nyquist limit should be 100 centimeters per second, or as high as it will go for the transducer you are using. Higher frequency transducers do not allow you to set a high Nyquist limit at depth. In some ultrasound machines, the baseline, or 0 point of the color flow Doppler scale can be raised or lowered to increase the Nyquist limit in the direction of the greatest blood flow. At normal velocity, blood flow through the valves is smooth and laminar. When blood flow velocity through a valve exceeds 1 meter per second, or 100 centimeters per second, turbulence develops. Color flow Doppler shows turbulence as a mosaic, or layering, of various colors. Color flow Doppler is very useful in locating abnormal blood flow, but cannot quantify the severity of a lesion.